Hi, welcome to Math to the Power of Science. Today we'll be talking about stardust. In my last video, I posed a question about what happens when a star starts to lose fuel. In this video, I will answer that. When the fuel starts running out, the fusion rate starts to decrease. And as you know from my last video, when fusion rate starts to slow down, gravity wins and starts to compress the core. This usually leads to an increased fusion rate because of the increase in temperature, but because there is no fuel left, the increase in temperature just starts to expand the outer layer, which then cools down due to expansion and starts glowing in the red spectrum instead of the yellow spectrum. This is the red giant phase, and unless the star still can fuse helium into other elements or those other elements into other stuff, then it will die. In a star with over 9 solar masses, 9 times the mass of our sun, the fusion has already occurred to the place where heavy elements have already started forming in the core. The problem is you can't fuse heavy elements because they're stable and you don't get much energy out of them. One other thing is the star becomes so dense because of the iron core that it literally collapses in on itself and forms a black hole. The gas around the newly black hole shoots into the black hole, but because there's so much going in, enough of it is pushed out, but not before it has a chance to fuse under the immense pressure. And this is where we get all the elements from uranium, tungsten, and other stuff. A star between 1.4 and 9 solar masses will go supernova. A star over 9 solar masses will still go supernova, it just goes in a different way. As before, the core starts to shrink and heats up the outstanding layers, but the core starts to shrink so much that it actually loses all of its protons and electrons until it's left with neutrons. The outer layers of the star will just burst out and fly off through space until it lands on anything. What you're left after the star goes supernova is a neutron star, a star that is made up primarily of neutrons, highly magnetic, and usually spins very fast. The last type of star is a star that is under 1.4 solar masses. This type of star will expand into a red giant and then slowly lose its outer layers, and will be left with a white dwarf. A white dwarf is the leftover core of the star that still radiates because of the excess heat. After it lets out most of its heat, it will cool down to become a black dwarf. There are other types of stars that aren't nearly as important, such as binary star systems, stars that orbit each other, and brown dwarfs, stars that failed to become stars because they were so small, about 1 times 10 to the 28th kilograms, which is about 10 times larger than the mass of Jupiter. Well, thanks for watching. Leave a comment down below or suggest a topic for a future video. If you like what you saw, please subscribe.